Hi friends, we can calculate the Newton's forward difference interpolation formula, and now we can calculate the Newton's backward difference interpolation formula. So we consider yn of x is equal to a0 plus a1 into x minus xn plus a2 into x minus xn, x minus xn minus 1, etc. So in forward difference formula, in this term is x0, but in this is a backward difference condition. So we put this x0 is xn, first term is xn. Now first we consider the set is xn yn, and the second set is xn minus 1 yn minus 1 up to x0 y0. So then they impose the condition y and yn of x should agree. The tabulated values xn, xn minus 1, etc., x2, x1, x0. So first we can calculate the constants a0, a1, a2, etc. So first we consider the first set of point. So in backward difference we consider the first set of point is xn, yn. So xn, yn, substituting x is equal to xn. So all terms are cancelled, only one term a0. So yn is equal to a0. And now we consider the second set of point. The second set of point is xn minus 1 and yn minus 1. Substituting x equal to xn minus 1 and y equal to yn minus 1. From that equation we get yn minus 1 is equal to yn plus a1 into xn minus 1 minus xn. So in this equation we can written as a1 is equal to yn minus 1 minus yn divided by xn minus 1 minus xn. We know that yn minus 1 is the nth backward difference. Nth backward difference operator. So from this we can written as yn minus 1 minus yn is minus of backward difference operator yn. And also we know that xn minus 1 is h. Therefore xn minus 1 minus xn is minus h. So a1 is equal to backward difference operator yn divided by h. And we can calculate a2, and generally we can written as an is equal to nth backward difference operator yn divided by n factorial into h raised to n. And we put x minus xn by h is equal to p. So we can written as this equation is yn of x is equal to yn plus p into backward difference operator yn plus p into p plus 1, the second backward difference operator yn divided by 2 factorial plus etc. p into p plus 1 etc. p plus n minus 1 divided by n factorial into nth backward difference yn. And this is the Newton's backward difference interpolation formula. This is the Newton's backward difference interpolation formula. So for an example, from the following table of value of x and f of x, determine f of 0.23 and f of 0.29 using Newton's forward and backward interpolation formula. So we get the x values and f of x or y values. So from this we can written as the forward difference table. So this is x0, x1, x2, x3, x4, x5. So we can calculate the fifth forward difference up to fifth forward difference. So we can written as the x value, y value, and first forward difference, second forward, third forward, fourth forward, and fifth forward. So from this we can written as the first forward, this minus this we get this. and this minus this, and also we can calculate. And the second forward is this minus this, so we get this term, and this minus this we get this. Also we can calculate the fifth forward difference. So now we consider, we have to calculate f of 0.23, that is x is equal to 0.23. So in this p, we know that p is equal to x minus x0 by h. So x is 0.23 and x0 is in forward difference table, the first term is 0.20. Substituting x0 is equal to 0.20, and h is the difference between x1 minus x0 or x2 minus x1, that is 0.02 from that table, and we can written as this equal to 1.5. And now we consider the Newton's forward interpolation formula. This is the Newton forward interpolation formula. So we get all the values. So y0 is the first value in this table, and y1, put y1 is equal to this, y2 is equal to this. First term in this tables, we substitute this. So we get y of 0.023 is equal to this. And now we calculate f of 0.023 in backward difference formula. So in backward difference formula, we have to find f of 0.023, x is equal to 0.023. So in this case, we know that p is x minus xn by h. So we know that x is equal to 0.023. And xn is the nth term. So in this forward difference table, nth term is 0.30. So substituting 0.30, and h is always 0.02. That's equal to minus 3.5. So from we can written as the Newton's backward difference formula. So this is the Newton's forward difference formula. Substituting the value of y5, delta y5, backward difference y5, del square y5 in this table. So delta y5 is this term, and first forward difference term is this. In the case of backward difference, this is that value, and del square y0 is this term and this term. Substituting in this equation, we get f of 0.023 is equal to 1.67512.